Alright, this is screencast number 4 for Unit 4, Lesson 3. I'm on page 210. What is Newton's law of action-reaction? Well, Newton's law of action-reaction, or Newton's third law of motion, states that whenever one object applies a force on a second object, the second object applies an equal and opposite force on the first object. Alright, red heading. Put a box around it. It's very important. Okay, all forces act in pairs. Okay, down at the next paragraph. Action and reaction forces do not act on the same object. Okay, so action and reaction forces do not act on the same objects. Okay, the forces are equal and opposite, but they're acting on different objects in opposite directions. So, I often get this question. Well, if forces are always equal and opposite, then how do we get unbalanced forces? Okay, and that's a great question. Okay. And I put something down here. It says forces occur in pairs, meaning that they're always equal and opposite. Well, then how do we get unbalanced forces? Because those equal and opposite forces are acting on different objects. Okay? So when you want to know if an object is going to accelerate, what you do is you think about all the forces, all the pairs of forces acting, and then you pick the forces that are acting just on that object that you want to look at. Okay, and I'm going to show you an example of that in just a second. Okay, so we have a situation here where a man is pushing on a wall. Okay, and if we really stop and think carefully about this, there's actually several things going on here. Okay, we have 4 pairs of forces. Okay, so the man is pushing on the wall. The reaction force is the wall pushes back on the man. Number 2, the man is the man. Pair number 3, the man, gravitational interaction between the man and the earth. So the man pulls up on the earth pulls down on the man. Okay? And the man actually would be falling or accelerating towards the center of the earth, except for the fact that there is a floor. So the man pushes on the floor, but in turn the floor pushes back on the man. The floor provides a supporting force for the man. Okay? I do expect you to sketch this on your notes section. Okay? Looks like that. Should be on the back of Lesson 3. I'm going to look at it when I grade Lesson 3. You need to have this sketch. You need to have all of the forces labeled, drawn, and the 4 circles for the 4 pairs of forces. So I will be looking for that. Now, if you notice with this sketch, 4 of the 8 arrows are shaded in red because those are the 4 arrows that affect the man and what winds up happening to him. Okay? So I'm going to draw another little sketch. I'll put it on the My Notes section and show you kind of where I'm going with this. Okay, so I took the red arrows from the previous picture, which you should have sketched, and drew a force vector problem, kind of like what we did last week, and showed you all of the things that are affecting the man. Okay, so for instance, this one is oriented up. This is the floor pushing the man up. This one would be the earth pulling the man down. This one would be the ground pushing the man forward. This one would be the wall pushing the man backward. Okay? And all of those would cancel each other out if the net force was 0. If they don't all cancel each other out, then he's accelerating somewhere. Okay? But those are the forces that are acting on the man, and I do expect you to label them. Okay, so I've labeled them. This one is an upward force because the floor is pushing up on the man. This one's the downward force that's equal and opposite because the earth is pulling down on the man. The ground is tending to push him forward. Wall is tending to push him backwards. Okay? And if everything is equal and opposite, he's not going anywhere. Okay, so the big law is that forces always occur in pairs. For every force, there's an equal and opposite reaction force. But the other thing that we need to realize is that those equal and opposite forces are acting on different objects. Acceleration is still possible because those equal and opposite forces act on different objects.